Pluto, a far-off and baffling smaller planet, was once an individual member of our solar system's planetary family. However, later alarming declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku brought Pluto back into the spotlight with a stunning disclosure. They suggest that this frosty world is on a potential crash course with Neptune. But how could this happen, and what might be the outcomes of such an enormous event? Are we witnessing an interesting cosmic phenomenon, or is there something else to this looming infinite crash? Join us as we investigate the potential outcomes of a Pluto-Neptune collision. Pluto, a previous planet that was downgraded to a dwarf planet partly due to its curious orbit, remains a subject of interest and study in the cosmic community. According to recent predictions by leading researchers, Pluto's trajectory is perilously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the warning of a potentially dangerous crash between these two planets that could be an immense threat to Earth. But how is such an event even conceivable? Pluto's journey around the Sun is unlike any other planet in our nearby planetary system. It requires a stunning 248 years to complete a single orbit. This means that since its discovery in 1930, it hasn't even completed one full revolution. However, the interest doesn't stop there. Pluto's path is marked by its highly elliptical shape, diverging entirely from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its inclination, calculated at 17 degrees to the ecliptic plane. The path Pluto follows is much steeper compared to the other planets. This inclination and eccentricity add layers of complexity to its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its convergence with Neptune's. For around 20 years in each orbit, Pluto actually draws closer to the Sun than Neptune, resisting what we might expect from their positions in the solar system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers struggled to grasp its unique path. Unlike the other planets whose orbits lie somewhat near the ecliptic plane, Pluto's orbit stood out with its steep inclination and eccentric shape. The mystery deepened with the realization that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit amidst these complexities is proof of the intricacies of celestial mechanics. The three-body problem in space is about figuring out how three objects such as Pluto, Neptune, and the Sun move and influence each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on one another. In Pluto's case, this problem shows how its path, Neptune's path, and the Sun's gravity all cooperate in a complicated way. Terms like asymptotic libration, scope libration, and VZK oscillation are part of this puzzle. Why hasn't Pluto collided with Neptune? According to astrophysicists, what keeps all planets in their orbits is a kind of libration. Regarding Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, its position is always at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from colliding. Scope libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, offering an extra layer of protection from potential impacts. Another critical factor in this situation is the VZK oscillation. Named after three researchers, VV, Apple, LV, and Chi, this oscillation explains how Pluto, Neptune, and the Sun interact gravitationally. Even though things in space may seem wild and random, certain patterns and rules keep everything in place. All of these factors help keep Pluto's orbit stable, ensuring it doesn't collide with Neptune or stray off course. The role of giant planets in Pluto's stability. Mathematical simulations in the late 1980s revealed that despite its stable properties, Pluto's orbit is actually turbulent. Minor deviations in initial conditions can lead to significant differences over millions of years. However, these unusual properties of Pluto's orbit have been found to maintain stability over incredibly long timescales, effectively keeping the chaos under control. Recent computer tests have helped scientists understand how giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune makes 3. This orbital resonance helps keep Pluto's orbit stable. However, Neptune isn't the only one helping. Jupiter's gravity also plays a large part in protecting Pluto's orbit. In fact, Saturn contributes as well. These simulations show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a steady path for an extremely long period, possibly even billions of years. It's as if Neptune, Jupiter, and Saturn are working together to ensure Pluto continues to move safely in space without running into trouble. The bigger picture. Pluto's orbit and the solar system. These peculiarities are vital in the larger context of the universe for maintaining order and consistency in celestial bodies' movement. Without these stabilizing factors, the solar system would be a place of far greater turmoil and unpredictability. Bodies like Pluto could potentially collide with others or be ejected from their stable orbits, leading to a domino effect on other celestial bodies. For Pluto particularly, with discussions about it possibly colliding with Neptune in the future, understanding its orbit is essential. It gives us a clearer picture of the solar system's dynamic nature. The influence of Neil deGrasse Tyson and Michio Kaku. So why are prominent astrophysicists only now raising concerns about a potential crash between Pluto and Neptune despite all these complex forces working to prevent such an event? Neil deGrasse Tyson, a renowned astrophysicist, offers a unique perspective on the mysteries of our solar system, particularly the captivating case of Pluto. Tyson, known for his role in Pluto's reclassification from a planet to a dwarf planet, provides insightful commentary on the evolving nature of celestial mechanics. Tyson's position on Pluto's renaming is rooted in the ever-expanding knowledge of our solar system. He sees it not as a downgrade, but as a necessary adjustment to our growing understanding of the many bodies orbiting our Sun. Conclusion. Pluto's orbit is a fascinating case study in the complex interplay of gravitational forces in the solar system. While its path is stable for now, the intricate dynamics between Pluto, Neptune, and the other planets mean that even the most seemingly stable orbits could change over time. As astrophysicists like Neil deGrasse Tyson continue to explore the mysteries of the universe, they help us better understand the delicate balance that governs the movements of celestial bodies. The potential for a Pluto-Neptune collision is not necessarily imminent, but it serves as a reminder of the constantly evolving and unpredictable nature of the cosmos. By studying Pluto, we also gain deeper insight into the early history of the solar system, planetary migration, and the intricate gravitational interactions that shape the universe. While the chance of a collision remains extremely low, understanding these cosmic forces is essential in unraveling the secrets of our solar system and beyond. Future disruptions to Pluto's orbit. While Pluto's orbit has remained stable for billions of years, it is important to remember that the solar system is a dynamic and ever-changing environment. The possibility of future disruptions to Pluto's trajectory cannot be ruled out, particularly due to external gravitational influences. One potential source of disruption is gravitational perturbations from unknown celestial bodies. Scientists theorize that objects in the Oort cloud, a vast distant region filled with icy bodies, could influence the orbits of known planets and dwarf planets. A passing star or an unseen large object could alter Pluto's trajectory over millions of years, potentially bringing it closer to Neptune or even ejecting it from the solar system entirely. Another factor to consider is the migration of the gas giants. The movement of Jupiter, Saturn, Uranus, and Neptune over vast timescales has shaped the solar system as we know it today. If any of these giant planets shift slightly due to long-term gravitational interactions, they could affect Pluto's orbit in unpredictable ways. While current models suggest stability, even minor deviations could accumulate over eons, potentially leading to new orbital configurations. The importance of observational technology. Our understanding of Pluto's orbit has been significantly enhanced by modern telescopic advancements and space missions. The New Horizons mission, which flew past Pluto in 2015, provided unprecedented data on Pluto's surface atmosphere and interactions with the solar wind. This mission not only transformed our perception of Pluto as a lifeless rock, but also helped refine orbital models with greater precision. Future space missions may provide even more insight into Pluto's movement and its interactions with Neptune. Advances in gravitational wave detection, deep space telescopes, and AI-driven simulations will continue to improve our ability to predict celestial movements with increasing accuracy.